Okay, so thank you. So I'm going to present this work that we've called using multiple accounts for harvesting solution in MOOCs. I just released the slides on my Twitter account in case someone wants to follow. I'd like to start first with a brief overview to get you engaged in slide 1. So what we're trying to do here is identify students who are making fake accounts with the mere purpose of harvesting solutions and then insert them with their main account in order to get credit for that. So this phenomenon has been termed as CAMEO, which stands for Copy and Answers Multiple Systems Online, or was termed by previous work by other researchers at MIT and Harvard. So our main goals are to study the amount of CAMEO in a third-term course that we're going to analyze, to find the motivation of students, why are they doing this, why are they following this methodology, and how it can be reduced, which are useful lessons for instructors. The course that we have studied is an MIT X course, which is about introductory physics that was delivered in edX. And some of our results is that 3% of the certificate students have used this method in at least 50% of their correct answers. That we find that there is more cheating on high-stake questions, and there is less cheating if we randomize questions and also when feedback is limited. So why is important this research? For two main reasons. The first one and most obvious is because it will decrease the value of certificates, but also because it will interfere with educational research, and I will discuss a lot about this later. Finally, we believe that this work is related to other works on academic dishonesty, since students are implicitly breaking edX Code of Honor, which says that you can only maintain one account. But it's also related to gaming system properties, since they are exploiting the system in order to get an advantage. And other related works are also the work I mentioned on CAMEO by MIT X and Harvard X, and also this second one, which deals with an intelligent tutor system online, which also detect this kind of behavior. So what are we actually trying to do? We have denominated a harvesting account, which is an account that is used to get the solutions from the questions, and then we have a master account in which students are going to insert these solutions. So basically, we do have a harvester account that makes a question one, then the master account makes the same question, and there is a delay between the two answers. And it can happen also in batch, such as we harvest question 1, question 2, question 3, and then we insert question 1, question 2, question 3. So how we are going to do this? We use an educational meta mining approach from the tracking laws of edX, and what we are trying to do is find patterns like this one. We have here oh, you don't see the pointer? We have here a so answer, which means that the harvester account is getting an answer for this question, and 15 seconds later we have here a check problem which was made by a master account, and so on. He goes again and gets another new answer, and some seconds later again, and so on. Okay. So this is what we are trying to operationalize in an algorithm that detects this kind of pattern. So first, this algorithm is going to collect all the events that are defined as a triplet of the harvester, master, and question. These events have the next features: that the harvester gets the solution for question Q, and then master submits it; that the harvester and master must share IP group, and for more info about this, please consult the paper; and the delay between the two events needs to be below 24 hours. And to be certain that we are not detecting false positive, we have a bunch of additional criteria, such as that the master never behaves as a harvester and vice versa. It wouldn't make sense that we find a harvester account that goes the other way around, that it's going to insert a solution made by the master. So that wouldn't make sense. So we delete all these events. That the harvester works for others, which means that the harvester account won't earn a certificate, that wouldn't follow the guidelines either, or that the most submissions are actually used by the master, which means that the questions that harvesters do are also later on used by the master account. And also that the master harvested at least 10 questions, which was 1% of the questions of the course. And all these criteria is with the intention of removing false positives. At the end, we will remove all the couples that doesn't adhere to this criteria. We made a final manual verification of the sample that we detected, which is similar to what I showed in the previous blocks. So let's get into the results. We have studied the introductory physics MOOC at MITx, and we have put a threshold of 5% of the questions attempted by students, which is around, the course had around 1,000 questions, so 5% was the around 20 questions, I think, or 10 questions, I don't remember well. And we have 500 certificate earners. So these are the overall detection rates. If we look into the certificate earners, that we think is the major issue here, we can see that there is 50 certificate earners, which are 10% of the certificate earners use this method and harvested at least 3% of the questions. But this also was a problem among non-certificate earners, and we'll see later a bit more about this. If we put these results into a graphic, what we can see in this graphic is in the x-axis, we see the percentage of certificate earners who harvested more than 1%, which means that here we have that 2% of the certificate earners harvested at least 70% of their answers, of their correct answers, which means basically that this 2% cheated through the certificate. If we find also more details about the characteristics of these CAMEO events, we can find that most users are using in a 53% of the time so answer, which is a feature that edX enabled where the student can ask for an answer, and this feature has different possible parameters of configuration. And 46% are using exhaustive search. And exhaustive search is what we call when a student is just clicking and clicking until it gets the correct answer by false and true feedback. Okay? So another thing that we found is that in 91% of the cases, the master account is going to insert the solution of the harvester account without even trying to solve the question first. So they go directly into getting the question and put it in without even trying to perform it as to solve it and use it as a help node. If we check the delay of the event, of the harvesting event and the submission in the master account, which is the one that we've been talking about, and we have a histogram here, what we find is that 90% of the events, of the cheating events, are found below 5 minutes. That the median is around 27 seconds, and the mode is 5 seconds, which means in 5 seconds, the students are cheating their answers. So this is a very, very quick and easy process. Students have 2 browsers. With one browser, they are harvesting the answer, and with the other browser, they are just plugging it in. Okay? In this plot, what we can see is a density distribution of the cheaters, which are in the master accounts, which are in red, the harvester accounts, which are in green, and the rest of the students, which are in blue. So what we can see here is surprise. Master accounts are the top performance of the course, harvester accounts are the worst performance on the course, and the rest of the students are just in the middle. Okay? And this was indeed very statistically significant, this difference between groups. And even more, if we check, in this case, in the x-axis, the percentage of submissions correct in the first attempt, and in the y-axis, the average time for correct submission, you can think that if the students are around here, it means that they are able to solve questions very, very fast. And if they're about here, it means that the students have a good percentage rate, okay? So you can imagine that the best students are around here, right? So you can see that this is full of red points. And red points are master accounts, okay? And the bigger is the red point, the more they're cheating. So surprise, the 3 top performers of the course are cheaters. Here we can compare this similar theme, but on time. So we have the different chunks of the course, which are the MOOC calendar. So these are the 2 first chapters, the 3rd chapter, the 4 and 5 chapter, and so on. And we can see this divided also in non-certificate earners and in certificate earners. The first thing that we can notice is that if the difference between the amount of correct answers and the amount of harvested answers, these 2 lines are closer, it means that these students are harvesting a higher amount of their correct answers. If there is more space, it means that they are harvesting a less amount of their correct answers. So in the case of non-certificate earners, what we can see is that the two lines are much closer than in the case of certificate earners. So actually, non-certificate earners are cheating a much higher amount of their correct answer than certificate earners. So this is one of the findings that we have. That non-certificate earners were cheating for a certificate, and we'll talk a bit more about this later. In the case of certificate earners, what we can see is that here is a very, very nice peak going down in the amount of cheating. So what happened here? 85% of the certificates were earned in this chunk. So what we found is that students, after they get a certificate, they mostly drop out. So if we take a look into this for individual cases of students, what we can see in this first case, student A is a student who is harvesting, the blue line is the amount of correct answers, the same as the last plot, and the red line is the amount of cheated answers. So this student is cheating completely through a certificate. This almost all his correct answers are cheated. Okay. This second student is a student which is has been cheating during all the course, but not that much. So maybe we still have hope, and he's using this as a backup mode, or as a help for the question in which they are having problems. We have here another example of a student C, who at the beginning didn't cheat at all in the three first chunks, and then suddenly he started cheating like crazy. Maybe he didn't know this, and he learned it later, or maybe at the beginning he had enough time, but at some moment he didn't have time to put an effort into this, and he had to cheat to get the certificate. And lastly, I have here an example of a non-certificate earner that I was talking about. We have a student who didn't earn a certificate, but he was cheating a lot until this chunk, and suddenly completely drops out. So we believe this, and this is not a unique student. There are a lot of students who are doing this. We believe that these students are just getting bored. They got bored and say, well, whatever, and they just drop out the course after almost having the certificate, because, well, with cheating there is no engagement. So these are the bad news, but we still have some good news. We found some reduction methods, and this is especially useful for instructional designers. Our findings suggest that if we use limited feedback in the course, we found that there is less cheating, around 3 times less, than if you use a lot of feedback, such as true, false, so answer, etc. And as you use randomization in the problem statements, you are able also to decrease it by 2 times. And this is statistically significant per student and per problem. So we found that it decreases also within the same student, but also across problems. So let's discuss about these results. The motivation, well, after showing these findings, I think it's pretty clear that the motivation is getting a certificate. The master is not even trying to solve a question before cheating. So is it any learning or whatsoever involved? Students are cheating more on high-stake questions. They are not stupid. They want to get more score. So they are cheating on those questions to be sure to get that score. We found a very abrupt change of behavior after earning a certificate, which goes in the same line. And an interesting finding was the case of non-certificate earners that they start with the intention of cheating for a certificate, but at some point they drop out. And we believe that this might be people that are really into cheating across different MOOCs. And in this code they had problems because this MOOC had around 1,000 questions. So as you can imagine, this is quite a lot of work to cheat through this amount of questions. So we believe this is a really problematic issue at the moment. 10% of the students harvested at least 1% of their solutions. And we even think that this is a relatively even large number, taking into account that this is only introductory physics. So why bother? What might be happening in courses which are really valuable for industries, such as data science or things like that? And that if MOOC certificates even get more important in industry, this will certainly increase over the years. So the implications, going back from slide 1, it can certainly decrease the confidence in assessment. We cannot trust if students have done the assignment by themselves by getting the answers with another account. And this will affect the value of certificates. it can interfere with MOOC research. At the first slide, you probably didn't understand why I said this, but now you saw that the top performance of the course are master accounts, the worst performance on the course are harvester accounts, and these two outliers and extreme sides of the population will interfere in most of your measures on educational research. And we believe also that it can apply to any other learning environment in which you can have multiple accounts. So it's easy for a student to just try to get the answer with another account and put it in the correct one. So regarding the remedies, again, put emphasis on this for future designers. Problems using randomized variables, we found that decrease cheating. For random variables, I mean statements in which you have a problem which has a variable that can change from an interval from one point to another. We even found a student who sent a screenshot to the instructor saying that last week he got an answer right, and this week this answer was no longer right. So what's happening, right? So we saw that we detected him as a cheater, and he actually sent a screenshot with the two answers, one right and one not right, and the statements were different. But he didn't notice because you only changed the number, so he didn't notice. And not only randomized variables, but also a pool of questions in the case you are using multiple choice can also help, but of course this is a lot of work. We also found that delaying and even removing, of course, feedback, and especially on high stake questions, because they are the ones that are cheated more often, can help a lot. And for feedback, it's not only the so answer feature that I talk about, but even the true or false feedback is also helping students to get to know if their answer is correct or not. The limitation of this study, well, this is an intrinsic internal validity. We have not a task sample in which we know for certain that students are doing this or not. We were not able to send an email to a student saying, hey, did you use several accounts to cheat to get your certificate? Well, we didn't have that info, so we don't know for certainly that what we are detecting is CAMEO. So our results to height, we are detecting 4 times more than the work done by Northcote et al. In our course. They send us the results by private communication. Or are we too low? If we compare to general literature on academic dishonesty, it says sometimes a baseline of cheating of around 50%. Can we generalize this study? We cannot yet because we only studied once, but we plan to keep working on this and broaden our understanding of the phenomenon. We're also starting to work on detection without relying on the IP of students. Based on problem features, student features, we already know that students are very fast cheating, so this is one of the key features. We could even implement with this information a runtime detection if people from the MOOC platforms are interested. This could work in the platform itself and block a submission if we are detected that they are following this pattern. And we also plan to explore other ways of copying. Since we saw also groups of students such as sharing answers and doing some unethical behavior. So that's all. Thank you very much, and I'll be happy to answer your questions.
Okay, well, I doubt there's going to be any discussion on this, but just in case, let me, and we would like to get the questions on mic, so the mic will come to you, and
this one is surprisingly. Oh, okay. So a question from here, maybe?
I'm the session chair, sit down.
Hello, my name is Jose Gonzalez Brenes. I work at Pearson. I have a question. So one of the remedies, so to say, that you suggested is removing or delaying feedback. However, there's a lot of research that suggests that the quicker we get the feedback to a student, the more they learn. So what do you think of the trade-off of, like we might prevent cheating, but like they might not learn as much.
Well, that's some people that might answer that to this problem is that they don't care about the people who are not trying to learn. They are focusing on the people that are trying to learn. So going in this direction, you are absolutely right. Why bothering these people who are not learning at all? Let's focus on the people who wants to learn and keep the feedback.
Right. Thank you.
Ken Kadiger, Carnegie Mellon. Just to follow up on that, I guess I like the way you said it at the end, which is on high stakes assessment. It seems like if you have something like a weekly unit quiz, yes, right? You don't actually have to give any feedback on the unit quiz and say until later, and certainly like in a final exam, you wouldn't have to give feedback in those situations. So if you limited the immediate feedback to the learning activities that led up to those high stakes assessments, that might be one way to get the best of both worlds.
I'm aware that this course is not maybe built on, similarly to most of the courses because it has checkpoints, it has homework, and it has quizzes. And the first one has, and the importance of each one goes from left to right, as I said. So what we saw is that people cheated less on checkpoints, which are the ones that typical ones that are after a video and say, no, did you understand this? And they give an answer and give a bit of points. And then quizzes are held weekly, and they provide a lot of more points. So yeah, you are saying that you can give feedback in the formative, and in the assessment not give feedback, and I agree completely. Just happened that in this course we were able to run this analysis because it was held this way.
I'll take chair's prerogative and ask a question, and then you're next. So at my university, sorry, Armando Fox from Berkeley. At my university, and I'm guessing at many others, when we can detect that there's evidence of cheating, we have a lot of the same problems you do. There's no guarantee of ground truth. We can look for patterns and things that are suggestive of it, but it's rare that we actually catch somebody in the act of cheating. But if there's a sufficient evidence, and I think some of the patterns that you're looking for would fit that category, we actually refer to the case to a disciplinary committee. They call the student in, they interview, they grill them. So they really try to get to the bottom of it. I don't know how scalable that is, but the reason they do that is if they determine that there was an actual cheating incident, the consequences can be severe for the student. So has there been talk about severe, instead of getting a badge, you get a scarlet letter, or you're banned from taking courses, like something to indicate that you were, some penalty that would follow an investigation, so that the students realize that there's actually potentially a negative consequence to doing this beyond the one that they're not actually learning anything.
Yeah, I guess if people are displaying their badges on LinkedIn, they can also display their cheating badges on LinkedIn, right? So maybe for that kind of experiment would be a good setting in the context on in-campus courses using this kind of technology, because you can have a higher control of the students and you can call them in and that kind of stuff. But for MOOCs, which I don't see very clearly how you are going to force them to come out and say that they've been doing that.
Giza from Stanford. So you found that when the responses were delayed, then the cheating fell 3x, I think. I'm wondering, presumably that suggests that they were doing the actual cheating very last second, right? Because then that's when you don't have time to actually go back to your master account and input the answer. So do you have any sense for how much of this cheating is actually motivated just due to deadline pressures, like it's right before deadline, they don't have time to do it correctly, so they'll just cheat and harvest?
Mm-hmm. Yes, I checked for that, and it was statistically significant that cheaters cheat. The submission of cheaters are more close to deadline than the non-cheaters, but it's not such a big difference. It's maybe, I check it in hours, I think it was maybe 12 hours or something like that. It's something not that alarming. It's not like they are just before. This is a pattern that people are cheating all over the weeks. So it's not possible that you are all over the weeks over the deadline.
And while we take the next question, may I ask the next speaker to come up and start setting up?
Hi, my name is Judith from Carnegie Mellon. Can you remind me why you're trying to get away from the reliance on IP as the for identifying students?
Yes, because when you have in the logs, when you have a submission, you have the IP from which this submission was done. So if you remove that, just by random, you are going to have a lot of students who are grouped together, and it's just a random thing. You can have people who work at the same time always, and you can even have people who work at the same time and share IP group, which because they might be in a dormitory, and that's why we add all these criteria, that there is not a vice versa behavior and things like that.
No, you said in your future work they are trying to get away from using IP and
to detect without the use of IP.
Yeah. So why do you want to do that when that seems like the most obvious way to?
Well, but because when they learn what we are doing is to get behind a proxy.
Well, hi, I'm Tom Staube from OpenHBI, and my question would be why don't you just show the solutions to these questions when the deadline is passed? So so there is no cheating anymore possible, or this way of cheating wouldn't be possible anymore. So why don't you go for that? So why don't you just delay the showing the answers until the deadline is passed? So that would kind of erase this possibility of.
So Appendix have different configuration parameters for so answer. You can either put it after the deadline, mandatory, but there is also a very frequent parameter, which is that you can use so answer after you have run out all your attempts. So you are supposed not to pick another new attempt, but you are using another account to get to run out of all your attempts, get the solution, and then go to the main one and put it in.
Okay, and we actually have time for one last question, and I believe you wanted to pose one. So.
That's the presenter's privilege. I was going to ask if you were worried about detailing your algorithm for detecting cheaters, because now I can game your detection algorithm to cheat even better. You haven't thought of that? You shouldn't have published.
You can even publish a paper about that.
Oh, yeah. How I beat your system.
Okay, let's take the speaker. Okay, next up, we hope